Hi, this is Mr. Reese, and this video is going to focus on postulates stemming from segments. And we're essentially going to be covering just two postulates. One called the Ruler Postulate, and the other called the Segment Addition Postulate. So how about we get started? Let's start off with what a postulate is. In some texts, you'll find that a postulate is simply referred to as an axiom, so they kind of go hand in hand. When one says axiom, it means the same thing as postulate. Well, both just simply mean that it's something that we know is true. We just assume that it's true. And typically, it's something that really hasn't been proved yet, but everyone just simply knows it as truth. The first postulate we'll introduce here is the ruler postulate. And you have to think about a ruler, what a ruler does. Well, with the ruler, you can not only draw straight lines or segments, but you can also measure. So in order to talk about measurement, you'd have to have a starting point and an ending point. So we have 2 points. The ruler postulate simply says this: if you got any 2 points, then with those 2 points you can measure how far it is between those 2 points, and you can connect those 2 points with a segment. So with respect to distance, let's say those 2 points are called A and B. A lot of times you'll be asked to determine the distance from A to B, like say on a number line. You can expect it to be written like this. You'll just see AB. You'll notice that AB doesn't have like a bar on top or a line on top. Like if you saw something like this on top, we would know that we're talking about segment AB. But since there's nothing on top, the assumption is that you're going to write how long it is from A to B. So let's say we have this number line. You can see points A and B here, and plus I added a third point, C. If you want to determine the distance from A to B, well, you can do one of 2 ways. You can just simply count. Starting from A, that would be 0, and then it's 1, 2, 3, 4. So AB would equal 4. The other way is to calculate. And the way you would calculate it is you take point A, which is located right here at -5, and you would subtract the second point, -1. Or you can go the other way. You can go with -1 and then subtract the -5. But no matter what, you're subtracting. Now once you get that solution, then you take the absolute value of that answer. And that's just to make sure that the answer is positive. If you switch around the numbers, the answer may be negative or maybe positive, but with the absolute value, there's just no denying you'll get a positive answer. So either way, we wind up with 4. That's all there is to it when it comes to distance. So how about from B to C? If you were to calculate it, with counting we can do that very easily, but let's assume that these numbers are pretty big for us to just simply count. If you were to calculate, we would take into account the -1 and the 2 because those are the starting and end points. So there they are, and remember that we subtract them. Then just make sure that the answer is positive if it is not already positive. And by the way, just so you know, if you put the bigger number first, it'll always come out positive anyways. But if not, just make it positive. So we have a distance of 3 from B to C. So how long is it from A to C? Well, if we try to figure out from A to C, we can use the same process, and that is we start with the first value and the last value, and we subtract them. But you'll notice we've done a bit of work already. We know that from A to B, it's length 4. We also just figured out how long it is from B to C. So if you want the entire distance from A to C, we can just simply do like we did the first time around, or just simply take 4 and add 3 to get 7. In a nutshell, 4 plus 3 is 7. That's how we got the answer, which means this. If you take AB and you add it to BC, you'll always get AC, assuming that they're in a straight line. And that brings us to our next postulate, the segment addition postulate. The segment addition postulate simply means this. You got 3 points, A, B, and C. And they're all collinear, meaning that you could draw one line through them, or segment. As long as they're collinear and in a straight line, then you can take AB, add it to BC, and get the whole thing, A to C. To be technical, this is what it would say probably in a geometry textbook. If A, B, and C are collinear with B being between A and C, then AB plus BC equals AC. Now, if they're not collinear, like you're seeing down below, then we can't really do that. You'll notice the distance from A to B, if you add it to B to C, well, it's not going to be the same length as from A to C. You can physically see that this distance here is shorter than the sum of these two. And that gets into a different idea called the triangle inequality. However, that's not for this video. Okay, so how about we do an example? Let's say that you are given that LV is equal to 60. There's our diagram. Determine the value of x. You'll notice that all 3 points are collinear, so we can go ahead and use this addition postulate, which basically means if we take the length of LU and add it to the length of UV, well, that's equal to the entire segment length. The length of LU is 3x minus 4, and the length of UV is 2x minus 8. Therefore, if we add them together, we should get the entire length of LV, that being 60. So that would be the setup for the problem. And then from here, you would just simply use some algebra. Just distribute that 3, and we get 3x minus 12. Go ahead and combine your like terms now. And then, once simplified, then we can use opposite operations. So here we would add 20 to both sides, and then to finish off, divide by 5. And that finishes off the problem. Last but not least, let's cover midpoint. Let's say you got something like this, and you're told that M is the midpoint of CD. Well, if it is the midpoint of CD, then this kind of follows the Ruler Postulate about measuring the distances between 2 points. If you measure the distance here between C and M, it should be the same as it is from M to D. That's what makes M a midpoint. Since it's a midpoint, that means that CM is equal to MD. Now, the way that you would show that is you would put markings on the 2 segments, like this. So you would mark here and mark here. And by the way, you can do more than one mark if you wish, as long as the number of marks on one is the same as the number on the other. So that's the way that you would show visually that 2 segments are the same length. Please make a note that here we have a different symbol here. This means something else entirely. If you have an equal sign, we're talking about equal lengths. But if you ever see this thing on top, they're also talking about the same shape. So the term for this, by the way, is called congruent. And we use this term not just to mean like one number is equal to another number, or that x equals 16, like the last problem. You're using it to talk about shapes being the same size and the same measurements. So everything's like the same length and the same angles and the same everything. And that's why you're also seeing the bars on here, because we're talking about shape. So physically, the length, the segment CM is identical to MD. And remember, you only get that if you know that M is a midpoint ahead of time. Here's an example. Let's say you're to determine the length of FB and FI. Now, hopefully you see these 2 marks. That means these 2 are the same length. So you should already have an expectation of how this is going to go. You know that from F to B, whatever its length is, it's the same as BI. And if you wanted to determine the whole length, then just take the length of FB and then you would essentially double it. Now you'll notice we're not told the entire length, so we wouldn't necessarily be using the segment addition postulate, in that you're not going to be adding this segment to this segment to get the whole thing. And we don't need to, because we know that B is a midpoint. And because of that, we know that this quantity equals to this quantity. So that's essentially is how you would set this up. So 2x plus 1 equals to 3x minus 4. Again, you would do this if you know it's a midpoint. If you don't know it's a midpoint, then we would probably be leaning on the addition postulate, and that we would be adding these quantities, but we would also have to know the length of fi somehow, some way. So that's a hint. Okay, just use some basic algebra here and solve this, and I'll just skip to the end. X is equal to 5. Okay, now that doesn't quite finish it for us though. In the last example, it said to solve for x, but in this one it doesn't state that. It says to determine FB, so we want to know that distance. Now since we have an expression for FB, and we already know what x is, we can go ahead and take 5 and just replace that into x right here. So FB is equal to 2 times whatever we plug in, which is going to be 5 because that's the value of x. And if we do that, we get 11. So now that we know that from f to b is 11, we also know that bi is also 11. So if you want to determine the value of fi, we can just simply add them up, and I guess here is where you would use the segment addition postulate. So we get 22. That answers fi. We got 11. That answers fb. And like that, you are done. That's it for this one. I'll see you next time.